Hello, this is question 6 on your international paper from edexcel, your M1 from January 2023, so one of the most recent now. So you have a boat is pulled along a river at constant speed, this is important, by two ropes. The banks of the river are parallel and the boat travels horizontally in a straight line parallel to the river banks. The tension at the first rope is 500 newtons acting at 40 degrees. So this is the rope, this is 500 newtons, and this is 40 degrees. The tension in the second rope is P newtons acting at an angle of alpha to the direction of the motion. So this is the second rope, this is tension P, and this is the angle. They say resistance to motion of the boat as it moves through the water is constant and is 900 newtons. So the boat is moving that way. I have a resistance to motion in this direction, so it's going to be 900 newtons in this way. The boat is modeled as a particle, the ropes are modeled as being light and extensible, we need to find value of alpha, value of P, and it's 8 marks, the whole question. So we are going to resolve forces, these two forces, in this direction, which is the direction of the motion, and the perpendicular direction. So I have this force here, remember it's going to be the value, which is 500, and this is the adjacent to the angle, so it's going to be cos 40, and then the other one, so let's say this one, is going to be P, which is the value, cos alpha. And if I work with the other direction, I'm going to have this one here will be P sine alpha, so P sine alpha, and the component of this one is going to be 500 sine 40. So what is happening here is that it's moving with constant velocity. There is no acceleration, which means the forces pointing that way together are going to be the same as this force pointing this way, because the resultant force is 0. And in this direction, force pointing that way is going to be force pointing that way, because I don't have any type of motion in this direction. So that's what I'm going to use to find P and cos. I'm going to write two equations, one for this direction, one for this direction, and solving them I will have my two values. So if I resolve, let's say first, parallel to the motion, I have forces pointing to the right is 500 cos 40 and P cos alpha. So I have 500 cos 40 plus P cos alpha is going to be equal to my force pointing left, which is the 900 newtons of resistance. And this is because I don't have acceleration in that direction. It's constant velocity. It says here, constant speed. Yeah. If not, the difference between these ones will be equal mass acceleration. Yeah, but acceleration is 0. And then parallel to the perpendicular to the direction of the motion, I have that this force pointing that way, 500 sine 40, is the same as this force pointing that way. So 500 sine 40 is going to be P sine alpha. And what I can do to solve these simultaneous equations and to find P and alpha, it's up to you how you solve them. I would just, for example, write P sine, I know it's 500 sine 40. This is a number with the calculator. So my variables are these two, but these are numbers. And then P cos from the first equation is going to be 900 minus 500 cos 40. And then if I divide them, P and P are gone. Sine divided by cos is tan alpha. And then when I divide this by this with the calculator, you find that tan alpha is 0.6217 something else, which means that alpha is 31.87 degrees to 2 decimal places. And that's the first thing they ask. The second thing is the value p, so I can go with this alpha to either equation. This one is simpler, so I'm going to go to this one and find p. So p is going to be just substituting. So I would put this value in the memory of the calculator so you don't lose decimals. Find sine and divide this value by your sine alpha, and then you get that p is 608.74 newtons to 2 decimal places. And that's it with this question. It's simpler than it looks, you see. It's just a few lines. Yeah.